The next gentleman, those of us at CIRI have been working with him for the past 2-week period. He was a late entry because we had a cancellation, someone could not make it, and he was intending to come here at any rate, and he wanted to get an opportunity to say something to us. Now, one of the things he has become an expert on is a computer virus. Have I got that straight?
That's correct.
And I was joking with him and some of his associates. This is Michael Rollins. I was joking with him and some of his associates the other day. And I said, please do not create an international incident. So he comes over here, and now Kinko's got the virus. And I think Larry's computer has got the virus. So this is an individual who is an expert in computer viruses. This guy Michael has been working, I tell you, it's got to be the last 3 days, night and day, to get his program together, running into all kinds of issues. And he certainly has earned a spot in our heart, and I hope you welcome him, Michael Rollins.
Okay, thank you. Thank you. Thank you. Thank you. Thank you very much for the invitation to participate. It's obviously a great honor for me to leave my home country and return to North America and speak about the work we're doing. I find myself in an esteemed company. I learn a lot from these things, and I attend quite a few, so I always go away with much more than I actually bring to the conference, but hopefully I can turn that around. Just so you know, I'm not a microbiologist, but I will be talking a little bit about microbiology. I've been very, very fortunate in working with quite a number of very talented microbiologists at UCLH and Royal Free Hospital. And obviously sometimes the brilliance and people like Stephanie Dancer that I get to rub shoulders with sometimes, occasionally it does rub off, so hopefully that will be demonstrated today. My involvement with the hospital environment goes back to 2001. I was actually working in North America at the time, and I met some gentlemen who had interesting antimicrobial technology, and we had a notion that we could actually modify healthcare surfaces to make them safer. I took that technology back to London, and we subsequently did a study at University College London Hospital, modifying surfaces in the infection diseases ward. In preparation for that process, we used steam vapor and microfiber cleaning technology to prepare the surfaces to take that application. At the end of the trial, I was brought in, and our consultant microbiologist and head of department said, well, congratulations, the trial has not been terribly successful, but we really love the steam vapor and the microfiber, and by the way, you're not taking it home with you. So that was our first set of trial equipment that we lost to the hospital, and they've been using it ever since. What did come out of that was that the head of department did retire 2 years later and moved under secondment to the Department of Health as a consultant for decontamination, and part of that was building new hospitals. And so we became quite good friends. We got to share a lot of opportunities to work together. But one of the things he did do, and I'm forever grateful to him, is he sprung £60,000 for me to work on a new study specifically looking at the application of steam and microfiber, and to look at both the application, the applicability of it, the utility of it, and also the commercial viability of implementation in our hospitals. So that's where it all started. From that, we learned some lessons, and we shared those lessons with the companies that we worked with, both in microfiber and steam. And it was really the starting point, the foundation to allow for a whole new realm of investigation. And all credit to these commercial companies. They've moved forward and they've invested heavily in good faith and with faith in our microbiology department to actually bring forward evidence that would assist them to develop and launch new products in the UK. Just to put, if I may, in perspective, the terms of reference within which I've been working, and I'm not going to dwell on these first two issues. Stephanie has covered them very, very well. It's just important to understand that when we bring forward some of these new initiatives, it's got to be relevant. There's no point in bringing in shiny new boxes or fancy tools if they're not going to be used, if they can't be employed, if there's resistance, if there's no money. These things have to be put in context, and obviously for me, I delight in when I see the government squirming and the Department of Health looking at issues. It's unfortunate this is reflecting in infection rates, but indeed it causes pain, and pain is actually a good motivator for change, and that is what has been happening in the last 2 years in the UK. These are the directives that we've been receiving from our Department of Health under guidance. I'm not going to go through those, but I just wanted to mention the fact that in here were some very specific directives that have enabled change to take place. And primarily the Health Act of 2006 firmly placed the responsibility for hygiene into somebody's hands. They became visible. It wasn't just these people over here. Unfortunately, they were in the hands of our chief executive and our director of infection prevention and control. They had to get involved, they had to get engaged with the process of cleaning and discuss all of the processes of cleaning with our domestic management staff. That was the start of the whole process of bringing this whole thing into perspective. The second part was the Going Further Faster program, which reflects the North American initiative for healthcare bundles. I personally like bundles. I look at integration all the time in the healthcare sector for environmental change. And this has been a very successful program. And this is really what it looked like. Currently, we have 7 initiatives there where they've basically deconstructed all of those areas where infections show up and look at, it's a risk assessment. And they've just put it back together again with good practice. And I looked at this and I said, well, this looks really, really good. And I know it's been very, very effective clinically. But where is the environment? And the only area that I can really hang in there is the fact that infection and that word presence of Clostridium difficile is the only part I can hang my hat on. And we take that on board as a challenge for environmental cleaning. So I sort of stick this on top. The hat that goes on the top is that the environment is everything, and that we need to implement good environmental practice to support our clinical initiatives. And if we have a holistic approach to hygiene and healthcare practice, that we create a safe environment for patients to be treated in, then we're moving forward on the path of reduction of healthcare-associated infection. You know, the old question, how clean is clean? Whose fault is this? These are actually UV lamps where when you take the UV away, they actually don't look too bad. The assessment to those actually passed visual inspection in one of the hospitals that we were actually studying. This is more to do with cleaning time and training, or lack of. Just last week, it was referred to this morning, there was a presentation to the American Society of Microbiology in Boston, and this was reported widely, I think, across the world, that disinfectant wipes designed to eradicate MRSA are helping to spread the deadly superbug because staff are using them to clean more than once. So it indicates that we have a failure of material, the method, the training, the lack of knowledge, insufficient research to work from. It all translates down to individuals who are going about with the best of intent to clean a surface but failing. We know that the amount of money we've been spending in the UK to decrease infection, we've been putting more money in and still failing. And we have to address how effective some of our processes are. And breaking convention is always a difficult challenge. But we do know that pathogens do remain viable in the environment for weeks or months, as has been illustrated today. And that some indeed outbreaks are attributable to the environment. So we have to remove those pathogens from the environment. And the choice we have is through physical force, through biocidal agent and or detergent. We have some problems. This is our armory historically that we've been able to look at in terms of our biocides, that halides, phenols, oxygen-releasing compounds, quats, have all been extensively used, but they've all failed in one or more way. And the problems associated with these are that they're harmful to health, they degrade the built environment, they promote potentially antimicrobial resistance, and with the degradation, that exacerbates the challenge of effective cleaning and cleanability of the estate. If your estates are broken, the surfaces are damaged, you cannot clean effectively. And cleaning is job one when it comes to dealing with the reduction of infection. These are some of the photographs that we found when we started to investigate our old hospital. I was advantage of being able to close an old hospital and open a new one, and we started to study some of our ITU surfaces. And you can see there is some physical damage there, but that dye stuff has just gone in. So where dye goes, biofilm can also set up. The varnish has been effectively removed from these wooden areas. We still have a lot of wood in our UK hospitals. And when you look at that under UV lamp, you see there's a very nice residue there of material, which when you start to clean it, smells rather interesting, to say the least. Again, destructive decontamination of a lot of our metal products with the use of chlorine. And there are issues with regard to patient beds, where the beds are now rusting from the inside out. Taya Daya, who's spoken in the UK quite extensively and is the lead on the Dutch Working Party for Infection Prevention. This is their list. I've modified it slightly. This is their perfect, they call it the perfect disinfectant. You'll see in a moment why I call it the perfect decontaminant. I've stolen their good idea, their list. I like it, I think it's fabulous, particularly the short action time, 1 or 2 minutes rather than 10. It just doesn't happen, certainly not our hospitals. That it should be compatible with materials, we shouldn't influence the environment with smells or create allergic reactions, and it should be safe and non-toxic and not harmful. And the one thing that we've been playing with notionally is that water is the miracle. It's not quite the silver bullet, but it certainly is the carrier for it, that we can actually employ very, very effectively using current technologies which are being refined as we speak. And namely, what I'll speak about today is steam vapor and microfiber. I bring these two technologies together. We have done studies individually on the performance of each, and they're both quite remarkable technologies. But when you put them together, the synergistic effect of these is actually quite remarkable, and it expands the utility of these systems to make them work for each other. Very quickly, and just as an aside, we implemented microfiber cleaning in our hospital some 4 years ago. We had the place in upheaval because our cleaners complained immensely. It was hurting them to use this material. And simply what was happening is the microfiber is such an aggressive cleaning method. It was actually sticking everywhere because of the residues that had built up over many, many years in our hospital, and the microfiber was trying to take it off in the first day. So as a consequence, we adapted the steam cleaning preparation to make it the surface cleanable, and we translated microfiber cleaning into maintenance and steam vapor as a support to that program. We then started to look at steam vapor more strategically. But just to finish off on microfiber, this is just part of the end of the study at UCLH where we looked at all of the hospital surfaces. You can see on the blue, these are pre-clean measures. Now these are all using ATP. And you can see consistently that we've got good reduction with the janitorial type of cloth, but in all cases, the ultra microfiber that we were using was consistently reducing those down to very, very low levels, and certainly within the acceptable levels that are currently now being promoted. This is microbiology. I don't know if you can see those very well, but those are actually contact plates where we actually did some testing on surfaces to show the performance difference between the janitorial cloth and the ultra microfiber cloth. This is our control. This is the inoculum. This is actually after cleaning the surface with the J cloth, and this is after microfiber. MRSA on the smooth tile, and this is completely clear of the organism. Acinetobacter we spoke about this morning, a very sticky organism. It sticks around in the environment very heavily. You can see here we have confluent growth on our plate. A number of colony-forming units left after the cleaning with the janitorial cloth, and again, a clean surface as prepared by the ultra microfiber. Our microbiologists were getting very excited at this stage, and we knew we had a starting point to actually go forward and really investigate the power of these technologies in their deployment in the healthcare service. As I mentioned, I'm not a microbiologist. My job in the hospital was to take these projects into the hospital. My main role was to look for failure and find ways around to fixing that. So I looked at things both operationally, practically, and hopefully intuitively, and brought that back to the lab for discussion and development of a cleaning strategy. This study is actually funded by a commercial company, Osprey Deep Clean. It's part of a large public company. They're based in the Netherlands and in the UK. They have an environmental focus and invest in the future. And they've been kind enough to follow through on these studies and provide the funding for this following research. We were not competent to be able to produce sufficient test protocols to develop standards or research which would withstand peer scrutiny, simply because there were no standards in place. We went to TNO, who's the Netherlands Organization for Applied Scientific Research. They certainly had the credentials and capability to design a study which we could deploy into the hospital environment. And together with University College London Hospitals, we undertook the practical application within a hospital environment. So TNO undertook work in their labs in clean room conditions to validate all of the aerosolization, dispersion, and decontamination tests in clean room conditions. Once those tools had been validated, we then took them into the hospital environment and repeated all of the studies to produce the statistical evidence that we'll present today. The definition of the study was we were looking at obviously safe removal of a measured contaminant, and that we were looking at the premise of steam not necessarily as a thermal disinfection quality, but one which would allow for penetration and physical removal of contamination from a target surface, and where appropriate, thermal disinfection could take place with susceptible microorganisms. But it was certainly not designed to be a thermal disinfection process. The objective was to observe and validate the effectiveness and the application of specialist steam vapor cleaning tools under a specified operating procedure in the removal of microorganisms from a number of different surfaces commonly found in the patient environment. It's a big sentence, but that's trying to encapsulate all of the variables that we were trying to achieve. These are real surfaces from the hospital environment dealing with real organisms, and we were trying to get steam from a box onto that surface and do its job. And that's in layman's terms, that's simply what these trials are set out to achieve. These were the original design concepts that were discussed and designed in the Netherlands, and this is the physical reality of them as we see them today that have been manufactured. I do have some of these here. If anybody's tactile and wants to have a look and a feel and touch, those tools are here to look at today. The surfaces we tested, as I mentioned, these are all typical surfaces from the hospital environment. We tried to get real. A lot of our hospitals are very old. They have old equipment in there. This is old kit. We didn't take nice, new shiny stuff. We took the beaten up stuff that was a bit crusty around the edges, and we took those into our mock-up environment, and this is what we tested. And we went through all of the typical surfaces of laminates, ceramics, plastics, nylon twill. This is mattress material. Textured vinyl seat covers, that lovely alligator type material that's on patient chairs, polypropylene and polycotton curtains, and chromium coated steel and powder coated steel that we would find typically on bed frames. We tested 5 tools, one that works with vacuum, one that works alone, the tube tool, and the 3 others which were actually designed to be integrated with microfiber. So now we were chasing down the holy grail. Can we put these 2 technologies together and make them work simultaneously and get more bang for our buck? So we had a single rapid process where we could get very rapid cleaning with very high levels of decontamination. These are all the organisms that we tested. We purposely contaminated all of the surfaces I showed you earlier with all of these organisms. You'll see that I've labeled here. Some of these are our own bugs. We actually harvested those fresh from our own hospital. Those were very real. These are library strains which we took specifically because they are requirements of the disinfection standards. But we preferred to be looking at what was real. We were looking at changing epidemiology in the UK. We wanted the toughest bugs we could find, and we sorted some of those out from our own hospital. We tested 2 machines, one which we would call more of a professional machine. This is something that task teams, rapid response teams would utilize. And we used our friendly machine. This is something that looks a little bit like a vacuum cleaner and is very easy to deploy on a ward, and it doesn't frighten anybody, whether it be the user, the patient, their family. And it was very, very interesting in looking at the performance of those 2 machines. Interestingly, there's quite a difference between their construction and their cost, but they performed relatively within the same realm. So we were very confident in deployment of either or of those 2 machines out into the hospital environment. The benefit, of course, of the commercial machine is that will run all day, all night, and perform consistently. This is much more of a semi-professional machine that wouldn't withstand to that sort of rigors of use. This is part of the design of the new professional ProVap machine. In part of the design, it had to be portable. We had to go to the disinfection. We were certainly not going to take contaminated beds and trolley them down a corridor and somewhere else to clean them. We wanted to clean them in situ. We wanted to have dual outlets here so we could use both vacuum and steam simultaneously. Or here, this is brand new, a lightweight tube which had a very, very flexible and lightweight hose on it. We could deliver steam and get into all those places that are very difficult to do. And you'll see very shortly the tools that are designed around that. We wanted to have water filtration so that this gives us the benefit of HEPA type filtration. Very few things will go through water. It separates out. And the benefit of that is when we trap it in the water, each time we empty that water out and we fill it back up with water, we have a brand new filter once again. So we optimize the performance of the filtration on every use. It also enables us to fully decontaminate the machine between transfer of patient areas. So if we've been in a known infected area, we can fully decontaminate that machine, including the filter, very, very rapidly and move on very safely. This unit here is what we call the decontamination tank. It's a dual purpose. It is the water filtration unit, but there is a very interesting, clever design in here. That's actually a steam channel, and when you plug the steam into here, that creates a sort of mini autoclave. So we can actually clean all the tools that we've been using, put them in there, hit that button for 3 minutes, and we will raise the temperature in there to 135 degrees C. So it's another minor design modification which helps to prevent infection. These are the tools. As I mentioned earlier, this is the end. This is the connector that fits all these pieces together. It's on the end of a very lightweight tool. This provides flexibility for the operator, and it minimizes fatigue. If you've seen normal steam machines, they have very large, cumbersome hoses. There's a lot of torque on that. It's very difficult when you observe people using it to see them to clean more than one bed before they want to go away and have a break. It's a tough job. These tools are designed to be used all day, every day with a minimum of fatigue, and actually to be enjoyable to use because they're lightweight. So these are all task specific. These are all part of our wish list coming out of the earlier study, is how do we clean beds? How do we clean drip stands? How do we get into all those awkward places that fingers can't get effectively? And a lot of it is we're cleaning blind. We're not going to flip things upside down. We're expecting people to get in and reach underneath and clean as best they can. And some of these tools, particularly this one here, allows for 360-degree cleaning, and the operator doesn't necessarily have to see what he's cleaning to have very good confidence that it's being achieved. And obviously we have the combination of steam and microfiber decontamination tools. I won't go through this. This is for the scientists in front of me. This is printed out, and hopefully you can read that. But this is the science behind the preparation of the inoculum, the controls, how it was placed. We purposely contaminated all of those surfaces. We took samples from those, and we used selective media, as was discussed earlier. So we were targeting in on the specific organism that we were actually testing at that particular moment using these selective media down here. And we recorded all of the colony-forming units before and after cleaning. And all of these tests on all of these surfaces with all of these organisms were replicated 6 times to provide the research tables. Before we could move on, we had to make this system safe. And aerosolization was the #1 concern of our infection control team. We had to measure this and validate this in the clean room at T&O in Holland before we actually brought this into the hospital. And this is just a description of the measures where we were using a 3-stage microbiological challenge impactor. All that means is that we were bringing the air in a controlled way through and laying it down specifically on plates. So we were catching at one end and laying it down. We had 3 stages, all with different size holes. So depending on the size of the organism, that's what we caught. And we were able to differentiate them quite quickly doing that. And that enabled us to enumerate very quickly the results. We used PTF tubing to make sure what came in the tube was delivered onto the plate. And we took all the measures during cleaning, and we took 28 liters down there onto each individual plate, which was then taken away for incubation. The start, this was day 1. So many microbiologists, so many microbes. It was quite a daunting task. And we didn't realize, we thought this was the start of 3 months. This was actually the start of nearly a year of testing by the time we finished. What happened was we actually went from a validation process to a development process. A number of these tools did fail, and we had to go back several times to the designers and ask them to start again, and we then started to retest again. And this is just day 1 when our colleagues from Holland came across to visit Nagat, my colleague from UCLH. She did all of the testing and sampling, you know, she's almost part of the family now. She's been with us so long. And this was a mock-up area which we took. It was a reconstruction of our decommissioned hospital. The experiments were conducted to evaluate the risk factor associated with steam cleaning using both standard and the new generation of custom design tools that we'd actually helped to define. And the evaluation method was based both on microbiological decontamination efficacy, but also within the context of patient safety as being absolutely paramount. We really wanted to take this kit as close to the patient as we possibly could. The closer we get to the patient, the more chance we have of getting the job done within the time frame available and actually getting the job completed on time and the beds and the equipment back into service. This is again just visuals of this is the 3-stage unit, this is the pump, this is the 3-stage sampler, and the hose leading to the point of where our measurements were. We did quite a bit of work using dye stuffs also and fluorescence. So we actually did work under fluorescent lamp to actually see what was happening when we were using the particular tools on a surface to check for any dispersion. This was the very first set of tests we did where we had actual cleaning going on. This bed is contaminated with organism Bacillus stereothermophilus. This is a microorganism for autoclave disinfection. This cleaning process will not kill those spores. This was designed to show that if we were cleaning and we were dispersing them or moving them from this surface area, these are the plates that were hopefully going to catch them, or the air sampler here, and there was another air sampler here, would actually detect them in the environment. This was a very early test at UCLH. We passed that test and shared that information with TNO, and they said, well, that's wonderful, but we want to make the test a little bit tougher than that. And that was the test. We went from being 0.5 meter and 1 meter away to 10 centimeters away from dynamic cleaning. So this is the test rig in the clean room at TNO. This is a steam and vacuum tool where we're taking an inoculated area here. We're cleaning this surface using that tool with steam vapor alone. There's no chemicals involved with this process. And we're measuring and extracting air at these 2 points through the 2-stage impactors left and right. We similarly employed the same process. This is a floor mop system. This is a prototype tool. We actually attached the tubes to the tool, so we were actually extracting from the edge of the tools. And you can just see here, I think, the inoculated areas within a 1 square meter level here. And I'll come to the actual specifications of the inoculum shortly. This is the early stages of the design of a curtain tool, is that we took a static system here and ran the material through. So we contaminated the curtain and pulled the material through in this method to emulate curtain cleaning. This one here, a little bit crude, but we actually purposely contaminated this curtain edge, and we cleaned the curtain, and we had 2 microbiologists tracking that manually on each side of the curtain to be within 10 centimeters and capture the aerosol, if any was created. This is one of the tables. I apologize. This is one where I could not get it to fit, but they're all just replicates. This is the mattress tool. This was testing C. difficile spores. We had approximately 100,000 spores per square centimeter. These are the 3 positions of the air sampler. And in the middle one was really where we were only picking up. But you can only see these are the results. There was 1, 1, 2 here, but very, very minimal numbers of spores. So we were reducing very considerably the microbiological load without creating any aerosol whatsoever that was discernible. TNO advises that any result underneath 10 was within the environmental background noise and acceptable. So the result was that we were able to conclude that with the correct selection of the tool and the cleaning technique, dry saturated steam does not cause an aerosol contamination hazard. This was very important because this was the starting point for then the decontamination trials. This is where we repeated now all of these processes where we contaminated things such as the beds and patient material and employed our cleaning tools, again rigged with the air sampling here, and tested both aerosol and decontamination simultaneously. This is one of the measures from again, the reduction of C. diff spores from a mattress surface. We were able to achieve a 5-fold reduction. This is equivalent, in our opinion, to what we would expect to achieve with chemical type cleaning. And in the UK, we're using chlorine at approximately 1,000 parts per million for typical cleaning of patient bed areas. So again, this is just our controls here. We're testing that the plate is fully contaminated, it's confluent growth, and post-clean, we're getting minimal results. These are absolutely totally clean. There's 1 spore there and 2 spores there. The test results were sent back to Holland. They said, well, that's great. You're doing a very good job of cleaning that surface, we think. but we don't believe you. We'd like you to repeat those tests, which we did, and the similar results came through. They then asked us to do a destructive test where we actually cut up the bed mattress that we just cleaned. And this is the mattress test that we did, and we put this thing in what we call a stomacher, a little machine that massages a little bag that contains our cut-out sample, and it will massage and release into the liquid what hopefully is on that surface. We were able to recover from our control here at 1.5 times 10 to the 4, so we were actually able to recover almost our original inoculum. And again, when we measured this in the stomacher, we were not able to recover anything on the original samples. This is just taking a sample directly from the stomacher, 10 mil. We would take a sample from that material. We then took it one stage further and then spun down through a centrifuge, that 10 mil, and concentrated what was actually in that water. And we actually were then able to find a very small number of spores, but again, within our environmental tolerance. So that was considered to be a huge success for bed cleaning. They were able to effectively clean a flexible surface using a rigid tool equipped with microfiber, using a normal cleaning technique within the time allowed for normal cleaning. So we were equal to the time and cost of cleaning, but we were producing substantially much better results. This is just a summary of, again, repeats where we were doing surface decontamination, very high levels of inoculum now onto these areas, stainless steel, plastic laminate, ceramics, the patient table, a nylon mattress, and a vinyl cushion. Again, all of our test organisms, and this is the table of all of the averages of the 6 replicate trials, and we did not get above, I can't recall, I think 7 was our highest. We were well within the threshold of 10 microorganisms, and this is the average of all of those tests. So this was actually quite a remarkable pass for this particular tool, this multi-tool, which is a combination of the steam delivery and the microfiber pad. The pad has now been designed and enhanced even further to enable strategy to show up. Our infection control people are very concerned about C. difficile. Other parts of our research were looking at microfiber, and while microfiber was extremely effective at removing from a surface, we then had difficulty removing the spores from the microfiber. This caused a whole challenge. Laundry was shown to be ineffective, and so we've now developed a process of attaching disposable microfiber to the tool. So we're now able to have all of the benefits of both steam and microfiber and the safety of disposability at the end of the task. We no longer have the problem of decontaminating a secondary surface. So in our conclusions that the biofilm removal was consistent across all of the test surfaces, including the plastic, vinyl, stainless steel, ceramics. We did have some challenges with regards to surfaces that were damaged or had designed into it surfaces of texture for light reflectance to make it visually soil hiding. I'm not quite sure where that fits within the healthcare sector, soil hiding characteristics. And this is a demonstration of the steam cleaning standard operating procedure. Now this is quite important because what we've now been able to demonstrate is that we can take and design a tool to address hospital equipment, challenge it with all of those microorganisms that are giving us problems in the hospitals, and now we're able to work out how to clean and define best practice. We can now teach that. So when we start to talk about now a standard operating procedure, we're able to deconstruct this process, the same as the care bundle. And we can show an operator how to clean that bed effectively in the time frame that they have available to them in a very concise and precise manner that would withstand scrutiny from our microbiologists. So now we're able to use that wonderful word, empower. People who've previously been disregarded as contributing to significantly to the team, so to speak, in the healthcare environment, to become very important frontline staff. These are the people who are in there and have the power to make a difference. And when I talk about empowering staff, you'll see in a moment, we can create extremely competent, very highly performant individuals, and they will enjoy getting on with the job and gain the respect and the confidence of their colleagues within the hospital environment, and that has been demonstrated. This is, again, another set of standard procedures using steam and vacuum where we're able to treat stainless steel and chromium-coated materials very effectively. These are water impervious, but still a textile which is suitable for the hospital environment that can be cleaned using steam vapor, and again, lots of stainless steel. All of these processes leave the surfaces virtually dry, so they're ready for going back straight into commission. Something like this chair would take approximately 30 to 60 minutes to dry completely and ready to go back into use. The flexibility of things like the flat tool, this can be hooked up, this can be used on all surfaces, whether it be wood laminates, painted surfaces, plastics. There's insufficient heat on any of these tools if using the correct technique to damage the surface. So we can now aggressively go after all of the wall cleaning and material cleaning with a lightweight tool and achieve very high levels of decontamination. This is, at the time we were doing this work, we were still using a prototype. This tool is still in development. This is a prototype of the steam mop. We now have the ability to actually do three-dimensional cleaning where we can clean both the floor and the vertical plane at the same time. But that's caused some difficulties in manufacture. But this is the original prototype tool that we used to do all of the testing and has set all of the design angles ready for the steam mop for production. And there's also a modified tool suitable for wall cleaning using the same technique, except it's just slightly smaller and enabled to work up to full ceiling height. So in conclusion, we define the implementation of dry steam vapor and microfiber as a technology or technologies that with competency-based staff training, they will provide, delivered by purposely designed tools, will provide cleaner hospital environments without the use of ecologically damaging biocides. We can achieve and demonstrate improved cleaning productivity. We can enhance daily and preventative maintenance through the creation of time. We can reallocate people's time more appropriately and strategically to do more work for less effort. We've been able to engineer into the tools much more performance that enables good ergonomic practice to take place. We reduce the damage to the material surfaces, which is obviously a very positive element rather than using chemical cleaning, and that we also improve patient safety in the use of the system, both in the application of the steam, that we're not causing any harm, and we're also removing the implications of odor or discomfort from using chemical cleaning around the patient. I mentioned earlier we did have stars. This is Sheena and Mina. These are two cleaners from University Hospital in Lewisham. They were the first to implement microfiber on our study back in 2004. They became media stars, and they're wonderful characters. They're both immigrants. They took to this. Mina particularly, she learned her English on our wards. She's been there for 25 years, and she became an absolute star. And she actually was the one person that convinced me that we could take somebody and train them in using these tools, and they could deliver a very high yield in performance. She really performed extraordinarily, and the results that we achieved from her activities on the ward were outstanding. I could tell when she took a day off from the results that came back to me from the lab or from our ATP test. I could tell when she went on holiday, and I could see the process of her recovery when she came back getting the shape. So these people are our stars. These are our future in terms of being able to achieve. So it's one thing to design the tools, but these are the guys on the other end of them. And this is a lovely story. I really do like this. This is about Mina. Not only was the floor shining with cleanliness, but the mopping was effected to the accompaniment of Neapolitan love songs sung in a rich contralto voice by the lady domestic cleaner. These are our real people. These are the ones that we can empower, that we can have on our side working with us in dealing with infection control. And when you explain to them their importance in delivering that, they really do come on board. And they are, I'm a very strong advocate for our domestic staff, and we have been testing enhanced cleaning using these technologies. We have done extraordinary jobs using these technologies. And I see I have a couple of minutes, and I'll describe a couple of those to you. But it's people that count. These are the guys who make the difference. And we're then able to create much cleaner and safer patient environments. This is our brand new hospital in London. It's now 2 years old. but as I mentioned earlier, one of the stories that we were able to achieve is that we lost some budget. We were going to have all brand new kit. This was the #1 flagship hospital in London. At the time, we were having a major national election, so it was politically sensitive. We were very concerned and almost to the stage of paranoia that we had photographers lurking around while we were transferring equipment and patients into that hospital. So I was charged with the project of making sure that every piece of equipment that came out of our old hospitals was transferred in here was absolutely squeaky clean. And the process that we actually used was microfiber and steam vapor cleaning. Over 10,000 pieces of equipment were cleaned using those two technologies while both hospitals were running. So we commissioned the new and ran down the old simultaneously, and we were able to transfer all of the equipment clean across to those two areas. We did have a slight blip in infection rates, but our consultant microbiologist and DIPSI agreed that we achieved a remarkable result in continuing to provide a very strong service and had very low incidence of increased infection as a result of the trauma of moving that across. This is a pilot study we started a year ago, or just over a year ago, where we took this lady here was a domestic cleaner. She's now cleaning clinical kit in the ITU. And not only is she cleaning with a patient outside of bed, she's now trained to do it with a patient in bed. And that has been studied. And that's potentially the future of where we can go, is when we talk about empowerment, we can actually take people who are now just cleaning floors and walls and basins and give them the power to be able to clean clinical equipment and provide enhanced service to our clinical teams in protection of the patient environment. It is possible. Technology is taking us there, and I'm grateful to those commercial organizations that have supported us, and I must acknowledge them that Osprey Deep Clean has been generous in their support and very supportive in the activities. And what started to be a 3-month study, 15 months later, we sort of struggled to deliver, but we're there now. And also to my colleagues at TNO and UCLH for their work and commitment to the projects. I'll be happy to take your questions.